Difference of squares is one of the more simple factoring methods. It only works when you have a binomial. The sign in the middle has to be a minus sign, and both the first term and the second term have to be squares. Here we have x squared minus y squared. Both x squared and y squared are squares, and it is a subtraction. So this can be factored with difference of squares. What we do is we write two pairs of brackets, because the answer to a difference of squares factoring will always be two binomials being multiplied by each other. The square root of the first term goes in the first position in both brackets. The square root of the second term goes in the second position in both brackets. And one bracket gets a minus sign, the other gets a plus. We can prove that this factoring works by verifying we multiply the two binomials we got by each other, and we see if it gives us x squared minus y squared as an answer. Using the FOIL, x times x is x squared. X times y is plus xy. Negative y times x is minus xy. And negative y times y is minus y squared. Since the plus xy minus xy in the middle will cancel each other out, we end up with x squared minus y squared, and that's what we started with. The difference of squares factoring method works. Let's try it with this one. We write our two pairs of brackets. The square root of 36a squared is 6a. The square root of 1 is 1. And we put a minus and a plus. Does it matter which one we put first? Here we put the minus first and the plus after. No, it does not matter. We can put the plus first and the minus after if we want. It just matters that one of them is a plus and the other is a minus. In this example, the square root of 4b squared is 2b. The square root of 9c squared is 3c. I put one minus and one plus and finished. Here we have x to the 4 minus y squared. X to the 4 is a square because any variable with an even numbered exponent is a square. The square root of x to the 4 is x squared. The square root of y squared is y. We put our minus and our plus, and we're finished. This might look like it's still factorable because we see it as a binomial, it's a subtraction, a difference, and we see that x squared is a square, but no, we cannot factor it with the difference of squares method because y is not a square. Here we have a couple of very weird looking examples. This first expression is a binomial. It is a subtraction and therefore a difference. And 9, 16, 49, and 4 are all squares. A to the 6 and c to the 10 have even numbered exponents, so they are squares too. This is a difference of squares. The square root of 9 is 3. The square root of a to the 6 is a to the 3. And the square root of 16 is 4. The square root of 49 is 7. The square root of c to the 10 is c to the 5. And the square root of 4 is 2. We put a minus, we put a plus, we put the same assortment of fractions in here. 3a cubed over 4 plus 7c to the 5 over 2. What we do is we preserve the structure of the original question in our answer, and we don't have to worry about the fact that it's a fraction. We're still able to square root every part of every term, and we get our final answer. Here we have some rather large exponents, x to the 8 and y to the 8. Let's apply our difference of squares method. The square root of x to the 8 is x to the 4. The square root of y to the 8 is y to the 4. We put a minus and we put a plus. And then we have to check, is there anything that's still factorable here? This is a sum of squares. It has a plus in the middle, it's not factorable. But here we have another difference of squares. We have to factor it because until then we are not finished. So what I'll do is I'll write two sets of brackets for the factors of this, and I'll copy down x to the 4 plus y to the 4. We have to keep showing all factors until we get to the end. The square root of x to the 4 is x squared. The square root of y to the 4 is y squared. Put a minus and we put a plus. and now we factored again. We're still not finished. We have a sum of squares, both of those are non-factorable, but here we have x squared minus y squared, that's a difference of squares. Its factors will be x minus y, x plus y, and the x squared plus y squared is carried down. The x to the 4 plus y to the 4 is also carried down. It took 3 steps before we were finished factoring this expression, and we used difference of squares on all 3 steps.